Hello, my name is Nelly Barret, and in this video, I will present ABSTRA, a system for creating small descriptions out of a large variety of data models. So first, let me ask you two questions. Have you ever wondered what is a dataset about? Or maybe have you looked for tools to generate documentation for the datasets you want to share? Indeed, these are very frequent questions. In the context of dataset reuse, the linked Open Data Cloud, which is a cloud of open RDF datasets, was containing more than 1,000 datasets in 2020. Also, a lot of other interesting datasets are shared as XML files, JSON files, relational databases, CSV files, property graphs, among others. Therefore, we can formulate the following challenges. How can we help the users to select the right dataset according to their needs? And how can we generate documentation automatically, for instance, to help the data producers to share their datasets? This leads to the following problem statement: how to produce a compact and expressive description out of any dataset. In fact, we want our descriptions to be expressive so that any user can understand it, and compact to not overwhelm the user and show only the most interesting parts of the dataset. For that, we rely on three principles. First, we seek a high-level and global description of the data, which will be easy to grasp for human users. Next, we focus more on the data meaning than the data syntax. And finally, ABSTRA is based on the idea that any dataset contains objects, records, or entities that may have a nested structure and that may be grouped into collections. When a dataset contains several collections, they are typically linked with relationships. In the end, we can say that ABSTRA uncovers the entity relationship model behind any dataset. Now, I will explain how ABSTRA works. So ABSTRA takes as input any dataset on the left and converts it to a graph. It also identifies the named entities. Next, it partitions the nodes into collections, and then it identifies the main collections and their relationships using one of the two techniques we devised. The first one is based on an original algorithm, and the second one is based on the PageRank algorithm. In the step number 4, we classify the main collection among a set of semantic categories, such as persons, organizations, or locations. In the end, we create the description and the entity relationship schema to let the user know what is inside the dataset. We also provide an interface to let the user play with the dataset. Now, I will show how ABSTRA performs on some examples. So here on the left, you have the graph that ABSTRA produced out of a dataset of 2 papers that has been both published in 2022. Given this graph, we wonder what are the main collections. ABSTRA says that the most interesting collection is the one of papers, or in other words, that the dataset is about some papers. Now, if we add some authors to the papers, what do we obtain? We still obtain in the description a collection of papers because the authors can be seen as belonging to the papers. Now, what if we add some conferences to this graph? In this case, we obtain 3 main collections. The first one is for conferences, the second one for papers, and the last one for authors. We have also identified few relationships, for instance, that the papers are published in conferences and that they are written by some authors. Now, I will show ABSTRA in action. So here we will load a dataset of few authors and few papers, and here you can see the log of ABSTRA performing on the dataset. Here you have 2 parameters to set the compactness of the description. With Emacs, you can set the maximum number of entities you want in the description. With CovMin, you can set the minimal coverage you want to reach. Concerning the classification, we have more than 1,000 categories. Here is a small excerpt. Now, to help the classification, we also set some semantic properties. For instance, we said that an entity having an address could be a person, an organization, an event, or a location. Now we will look at the description that ABSTRA just produced. So on the right here, you have the entity relationship schema showing the two main collections and a relationship. The pink box corresponds to the authors, which has been classified as persons. The orange one corresponds to the papers, which has been classified as a creative work, a very general category for human works. And you also have the relationship linking the authors and their papers. On the left, you have the textual description showing the same information, plus some statistics about the properties of the entities. Now we will look at another dataset abstraction that has been built on a dataset describing some persons that have sold some products through auctions. So here on the right, you have the entity relationship schema containing 5 main entities, namely the persons, the open and the closed auctions, the products to be sold, and the categories of the products. On the left, in the description, you can see that some properties may have a nested content. For instance, the address is composed of a street, a city, a country, a zip code, and sometimes a province. Now, I will show you the interface that comes with ABSTRA. So in this interface, we have loaded a set of articles coming from PubMed, a well-known website of biomedical articles. So this blue node is the collection of articles, and the 3 red nodes are the articles themselves. You can see that in red, we have also identified authors. To conclude, ABSTRA is an all-in-one dataset abstraction system which is able to produce user-oriented descriptions. You can find more on the ABSTRA website. Thank you for watching.